Hello, everyone. Good morning and welcome to today's webinar, Driving Innovation Through Acquisition. My name is Charles Lutz and I'm part of the business development team at Software Improvement Group, also known as SIG. Let's start by looking at the agenda for today's session. First, we're pleased to have Ted Schadler with us today. He's a vice president and principal analyst at Forrester Research. Ted has 29 years of experience in the technology industry, analyzing the effects of disruptive technologies on people and business models. Ted will be presenting highlights taken from his research on how smart companies are making startup acquisitions part of their digital growth strategy. Next, we have Jasper Geurts, Director of US Consulting at SIG. He'll expand upon some of the themes that Ted introduces, but focus more on the how. For example, when you decide to acquire a company, how do you objectively measure if the target acquisition will align with your roadmap? And how do you measure product, process, and people risks prior to acquisition? With over 12 years hands-on technical experience, including 6 years at SIG, leading dozens of IT due diligence and software risk assessment projects, Jasper is well positioned to share insights and experiences. Time permitting, we will conclude the webinar with a Q&A. You may enter questions at any time during using the Q&A feature at the bottom middle of the screen, and Ted and Jasper will take them at the end of the session. And with that, I'm pleased to hand it over to Ted Schadler. Ted?
Thank you, Charles. Hi, everybody. Let's see. I need to take back the, oh boy. Here's where I'm going to mess up, Charles. I don't seem to see how I take back the bar. Here we go.
You see it, the share?
That I see. Yes, it didn't let me. I cannot start screen share while the other participant is sharing, it says. All right, let's try that. There we go. Wow, we didn't plan for that one. We practiced and practiced, and we didn't plan for that one. So thank you, Charles, for that. So hi, everybody. Ted Schadler here. So we did some research a few months ago, and this kind of builds on a lot of work that I've been doing over the last 20 odd years to think about how do we source innovation? How do ideas come to life through software, and how does that enter the market? And how do companies and people and societies, frankly, take advantage of that innovation? And as you know, a lot of the innovation is funded by investors and created by entrepreneurs. And that just has been a massive source of ideas coming to life. And what we wanted to do is to look at that kind of systemically, and understand how not just other high-tech companies could acquire startups, but how enterprises, how our enterprise clients can acquire startups. And so we focused on how to acquire startups as part of a growth strategy. And so that's the research I want to present to you today. I think it also leads very directly into the rest of the webinar about how to take advantage of the capability while making sure that you manage the risks associated with it. So the agenda for my section is that startups are the raw material of technology-based innovation. That's a theme at Forrester we believe very strongly in, as I said. Emerging technology, and I'm going to highlight 3 of them, enables sometimes radical business model change. You can do a completely different thing, or you can do an old thing in a completely different way using some of these technologies. And then I'll close with how to approach your acquisition opportunity with confidence. What can you do to be successful? So let's start by looking at venture scanner data around investments in startups. Kind of long story short, we've got not such thousands, but actually over 10,000 startups invested in, and they're in every single part of the market. They're in industries like financial services and retail. They are in domains like marketing and security, and they're in technology like IoT, for example, or edge computing. So there's a tremendous amount of innovation coming, and what you see here on the right-hand side are the number of companies in each of those sectors, and the size of the box is a commensurate. So long story short, there's a lot of raw material out there for innovation, a lot of places to go to look for new ideas expressed in code. So what's interesting to us, and we have some analysis here that I'm not going to show you in terms of some charts, that show that it's not just a single sector that's acquiring, it's every sector, whether it's financial services or manufacturing or telecommunications or retail or life sciences. It's acquiring technology, and they are acquiring technologies in these different domains. So here we have 6 of them highlighted: retail, IoT, AI, and so on. And what you see here is the number of acquisitions in that startup category over the last 10 years or 7 or 8 years here. This has continued, of course, because the amount of investment has also continued. And so when we went and probed on why do companies acquire startups, we learned quite simply that it is about innovation, transformation, and growth. So first, to advance a product roadmap. So you've got something in place already, you know you want to do something, but you want to accelerate it and jumpstart it by acquiring a piece of technology. This is a lot of what's going on in fintech, for example. So a bank might have a strategy, but they acquire a fintech company to really accelerate that. They can launch a new business. So if we're going to get into a direct-to-consumer business, for example, we might need a whole different model for going to market, and we might want to use a startup for that. And then lastly, to plug a technology hole. So if we've got a strategy in place already that's technology-driven, but we've got some gaps in it, maybe we have an IoT gap, or maybe we have a conversational interface gap, or maybe we have an AI gap, well, I can acquire a piece part and plug it on into that product strategy. So lots of different ways in which companies are thinking about bringing startups into their company in order to take advantage of it. Also, just to leave you with a very clear sense that this is accelerating. It's not a one and done phenomenon. It's a little bit cyclical, as you'd expect. But right now in this rising economy, this massive investment, I also think it's a structural change. I think companies are more and more looking for ideas to come outside and move away from the not invented here barrier that has prevented them from taking advantage of partnerships and also of acquisitions to grow their businesses. So it's not just a sort of a cyclical rising phenomenon due to the economy, it's also a structural change in how companies source innovation. So we do not expect this to slow down dramatically, although it may taper a little bit if the economic conditions change. So that's kind of the startup here, is just to understand that there's a lot of raw material out there, and to get smart about which ones are best for you is going to take some effort. A lot of it is technology driven, and we'll get to that in the last section here. But I want to probe on some technologies that I think are particularly interesting and meaningful in terms of radical change. And so to do that, to set that up, I want to remind you that at Forrester, we're very data driven. I showed you the venture scanner data that we summarized. We also survey influencers at companies, so business decision makers and IT decision makers. And when you say you care about innovation, well, what are you doing about it is the question here. So what are the key actions your firm is taking to achieve your objective of improving your ability to innovate? And the first one here is to invest in emerging technology. Second is to really have a deep understanding of the changing needs of customers, not just what you have to sell, but what they need. That allows you to blue sky your business, to think completely differently about how to fulfill those needs. So that's a good way to come outside in, we call it at Forrester. And then, of course, allocating budget, improving collaboration and processes. But the number one is investing in emerging technology. So again, at Forrester, we have a regular process for assessing technologies. And what you see here, I'm going to move this around a little bit so I can see it myself, is that we've looked at and identified, this is my colleague, Brian Hopkins, Bobby Cameron, there's about 8 or 9 analysts involved in this one, looking at these emerging technologies and then plotting them on 2 axes. So new, not new on the bottom, and narrowly implemented versus broadly implemented up to down. So for example, edge computing is very new, and we expect it to be quite broadly implemented. Augmented and virtual reality, not all that new. A lot of companies are investing there already. So a little bit more narrowly defined is the use case, but an important use case that you can do to solve things like field service, for example, or marketing or training. Deep learning, we expect to be very broadly implemented and it's coming into maturity. So that's just an example of maybe different horizons of maturity you might think about here. So I want to highlight a couple of them. So let's see, here we go. So the first one is computer vision. I was trained as a physicist, and I like to think about stuff that's sort of at that, I'll say quantum level, but stuff that's sort of fundamental. And vision is one of those fundamental things. If I can use a laser to see, if I can use infrared to see, if I can get out of the visual spectrum to see, if I can do radio telemetry to see, these are all different ways of seeing. And computer vision is another one. And it's a very, very important one because, of course, we eliminate and remove people from the mix. We instead train a computer to see something. And I have cats or, the one on the internet. And there's a lot to go here, and a lot of mistakes can be made, and how you train it is a problem. But there's some radically different things you can do with computer vision. One that I heard recently that I was fascinated by was a grower. So these massive greenhouses in Spain, in this case, for growing vegetables, fruits and vegetables. And what they've done is they've put, I'm reaching up here, you can't see me. They've put cameras in the ceiling of this. They're closed, they have irrigation, and they can actually, with this camera, they can spot and identify 15 different diseases on the plants. And they can spot it early enough that they can actually intervene with, they don't call it medication, but whether it's an insecticide or a fungicide, a way to address the problem. 15 different kinds of diseases using a camera. That's an example of computer vision. They can, of course, it's fully automated. They can check the soil for moisture. They can figure out where is it lacking fertilizer, so if the plants turn a certain color. So computer vision allows them to scale this up in a really interesting way. That's just one small example of computer vision. There are many others. So it's a good one to keep an eye on, because these fundamental building blocks, these capabilities, might plug into your world in a way you hadn't really thought about before. So that's just one example. Another example would be deep learning. This one scares me a little bit, but I think we're all gonna have to get used to it. And by the way, we're also gonna have to insist on some visibility. Deep learning is where you feed a machine, a computer, massive amounts of data, and you don't tell it how to interpret the data. You let the machine, if you like, figure out what patterns are, and then it builds its own associative meanings. And then you might find something crazy out of that, and you might coach it a little bit, you might train it a little bit, but what's really going on in deep learning is it's identifying new ways, new patterns, new ways to solve problems that you as a human wouldn't necessarily have algorithmically been able to predict. Now, the opportunity there is massive, because we can optimize. One of the examples we heard recently is Amazon uses deep learning a lot. And one of the things they've done with deep learning is to figure out how to optimize inventory placement in the warehouses, so they can do more same day or next day delivery. And so they've improved it something like 15 times over the regular old AI algorithm. They've improved their predictive ability to place inventory by a factor of 15 by using deep learning. That's not a small change. Now, the one thing I would say about deep learning is we want to insist that the algorithm tell us how it made its decision. We effectively want to be able to put that AI, that deep learning AI, on the witness stand and interrogate it and figure out how it decided what it did, why it did what it did. This is very important for confidence, for feeling confident that you can trust the decision that it made. So our society is still kind of working through that. But for deep learning, you want to be looking for these places where you can feed it a lot of information and have the machine figure out the best optimization path, the best forecast, the best predictive. Very, very important, very broadly applicable, and coming obviously into fruition now. Another example is we call it distributed ledger, distributed trust systems at Forrester. So blockchain is a good example of that. When you think about distributed trust, our world has been built around effectively intermediaries and around regulations, so that if somebody writes a check and I get it, I trust that check, I can deposit it. And there's a whole infrastructure built around that. Now, where Bitcoin and the other currencies have come in is they've sort of eliminated that intermediary of the bank. That's interesting, probably, but not the most immediately interesting to most companies. What's more immediately interesting is things like supply chain provenance or smart contracts, things that there's already a standard in place and there's already a mechanism to assure trust. And then these distributed ledgers allow you to, with confidence, sign it, attach it, digitally sign it, attach it, and know that the provenance of it is assured. So if a tomato comes from a particular field and it turns out to have a disease associated with it, you know which field to go after. So those kinds, and that's going on in really all aspects of the supply chain. It's going on in banking and treasury. It's going on any place you've got a lot of players that need to have assurances and to build trust for each other. And so again, broadly applicable, very interesting, sometimes a radical change in how things get done. So those are three that I'm particularly interested in. Well, okay, so I've talked a little bit about startups being the engine, if you like, the raw material of innovation. I've identified some that I'm quite interested in. You I'm sure have others. Now I want to shift gears and give you some guidance as to how to think about your opportunity and what your responsibilities are for making sure that what you acquire actually is going to work. So there are quite a few challenges that firms face in acquiring and integrating tech startups. They fail to get to know the startup landscape. They might read the press or get venture scan and they think you're done. No, that's not enough. You actually have to build an understanding of the founders, the investors, the maturity, who else is in the market. So that could be a real problem here. We also find challenges in knowing it is what you're buying. There's a lot of hype, a lot of garbage out there, frankly, in the press. So if you don't know what you're buying, then obviously that's where due diligence comes in. In doing due diligence, and there's two kinds of due diligence. There's sort of pre-deal due diligence where before you make a bid. Then once you make a bid, there's a second round of due diligence where the deal is essentially inked. There's an agreement, but it's not signed yet. And it's a sort of a level of understanding you're going to acquire. You get to do another round of due diligence. And here, the bar is much higher for rejection. You'd have to find a really egregious problem in order to walk away from that deal, or else your credibility as a buyer is destroyed. So again, two stages at which you do due diligence. And each one of those, you want to be thinking about things like code quality. Is the code going to work? Can you maintain it? The development processes, are they robust? IP ownership. Does this company actually own the IP that they're selling you? And then key person risk, where there's a founder or a developer that turns out to be critical to the success of the software, the product, and there may be some risks associated with that, of course. And then lastly, companies underinvest in the transformation needed to integrate the acquired assets. There's a real commitment you have to make sure that the onboarding and the integration happen. So you need to invest appropriately in that. All right, so what we did was we went out and talked to companies willing to talk to us. This is a very sort of secretive world. People don't want to talk. But a lot of our high-tech clients were willing to talk to us because they see it as strategic. And so we talked to about a dozen of them, roughly, as well as some investment bankers and some management consultancies to do this kind of work. And so here's what they told us. You need to identify a business owner. This is not a technology-driven thing typically. It is a business-driven thing. So you need a business owner with profit and loss responsibility. So if corporate development is wanting to do it, they also have to find a general manager, a vice president, somebody who's willing to take it on and actually make it a success. You definitely want your corporate development team to lead the vetting and the negotiation process. You don't want to do this within your own team. You want to take advantage of the resources of your firm that's typically housed in corporate dev, sometimes as corporate strategy, to do that. You want to establish an integration team to handle every aspect of it. This is a team that might come together for a one-time integration, or it may come together regularly. One company I talked to does about an acquisition every quarter. And so they have a loosely affiliated integration team. We have another that does an acquisition basically every couple of weeks. And they have a permanent integration team. So you need to think about how much to invest in integration personnel, but you want to make sure you cover all the parts, the tech, the people, HR, the systems, so collaboration, email, the cultural integration. So we want to establish that team. Now, we believe at Forrester that the role of the IT organization is very important here. And we're going to come back to this later today, I believe, but I want to leave you with some very specific guidance for CIOs and chief technology officers to really step into a leading role. You know what the technology architectures are of your industry and of your firm. You've got a vision for the technology that nobody in the organization has as well as you do or should. So you want to build relationships with startup founders aligned with that architecture. If you believe, for example, that blockchain is going to disrupt your business, you better be getting in on that to know what's going on. You want to get to know the whole ecosystem, not just these handful of founders, go to the conferences, but which investment bankers matter? Which startup conferences should you be going to? You got to get in the game. You need to, of course, accept responsibility for assessing the quality. We're going to spend a lot of time talking about this today, so I won't spend more time here, but you may not be able to sink a deal, but you can certainly mitigate the risks of the deal, and you can improve opportunistically the success and the value of the deal. And then definitely don't do this on your own. You probably don't have this expertise in-house. You want to build some expertise for sure, but you want to work with experts. You want to work with investment bankers. You want to work with management consultants where it makes sense. You want to work with organizations like SIG that can help you with the specifics around some of the very difficult assessment things that you're doing. So that's what I wanted to leave you with today. Massive engine of innovation in the startup world. Some technologies that I'm quite interested in. You have others, I'm sure. And then technology organization has a responsibility and an opportunity to step into a leading role. So I'm going to leave it at that and pass over to Jasper to kind of carry us forward here. And I guess I should stop sharing to make that easier for Jasper to do.
If this works for me. I think that works. You can see my screen.
Yes.
All right, so thanks a lot for that, Ted. And we are indeed one of those partners that can help out with getting the right information on the table when you go into such a transaction. But before I'm going to talk about that, I quickly want to introduce our firm. So the Software Improvement Group was founded in the year 2000 by a bunch of researchers in a research institute in Amsterdam. It's part of the University of Amsterdam. And these guys were doing a lot of research on the Millennium Bug. So can we find models? Can we invent models that would predict that and that could help the clients back then, or at least the ones that challenged them, to mitigate those risks? And this is basically what spun off, because they found great models that could predict that. And this actually spun off this commercial organization that we are now 20 years later. So our mission is to help firms create a healthier digital world. And we are a consultancy firm that uses a lot of technology to focus on software quality, assurance of quality risk, and also costs. So science is still a very important part of our organization. Highly educated staff. Everybody has an MSc, and some of them have also PhDs in software engineering related fields or business administration. So the way that we work is we use ISO certified approaches. So we have a software laboratory that can actually analyze all kinds of different programming languages from various technologies. And we've done this for such a long time. So we build up an extensive database and knowledge on what direction the software engineering industry is actually heading towards. So what we do, we have advisory service where we look at risk, modernization assessments, for instance. Also, what Ted pointed out, IT due diligence. So what is it, what we're actually buying, and where do the risks lie in the code? We also build our own technologies that basically can be very helpful for developers, architects, but also CIOs to get continuous insight in what's going on, so to say, under the hood. So back to the topic of this talk. I actually came across a very interesting blog post in my LinkedIn feed, which basically said that always the plan, if you want to acquire a company, you want to build up the value, and you want to, if you're a strategic investor and you want to build out your roadmap using this technology, you want to have a successful integration in a significant, or in a time frame. You have a plan for exit. But what we see a lot in our practice is that once all the champagne corks are basically in the corner, and we open up the code, there's this huge IT surprise, which reduces value initially because there's not a lot of rework needed, which also extends the integration plan. So in my section of this webinar, I'm going to talk about what are actually the things that's inside of the IT surprise, and how can we actually know or get enough information before going in a transaction of a tech startup. So we identify 3 key elements, and I think Ted, you mentioned these as well, right? So you need to think about the product, you need to think about the people and the process. So when you think about the product of a tech startup, you can think about the business value that you see in such product. You can look at the UI, you can look at all kinds of different aspects that you need to speed up your roadmap. So when we as SRG look at the product, we look at it from a very technical perspective. We look at all the artifacts that are foundational of running this solution in production. In other words, the source code, the test code, the configuration files, the data model, architecture, all the really technical, complicated stuff, because that's what the real product is about. And when we talk about people, you know, founders are very important, HR, financial, there's all very important people inside of a small tech or scale-up firm. But the people that actually build the code are very, very important for maintaining the code or adding value to the code. So we look at it from that perspective. And in terms of process, this is basically everything that facilitates streamlining this software development lifecycle, meaning the methodology that they use. Do you do your waterfall or do you have agile methodologies? What are your test procedures? What is your documentation? What do your code standards look like? So these are basically the topics that I'm going to discuss in this section. But there's one thing that we as SRG see that is very, very crucial if you compare these 3 elements. And that's the product, because the people might leave and the process might change. You might influence the way that people, you know, build code, but the product is the actual thing that you buy. So let's dive into that a little bit deeper, because the product is always changing. That's basically in fact, what emerging technology means. You saw that in Forrester's research where there's a certain maturity for technology. This means that it's continuously changing, and this also means that you probably, there's a really big chance that you need to change a lot of code. So even if you want to just integrate it in your current landscape, in what you already have, you are going to need to change code. But definitely, if you want to add value or get it into a more mature state, you definitely need to change code. And that's the point that I'm trying to make here. So if you want to change, if you know that you need to change code, then you need to understand what the code actually does, how it looks like, before you're going into the transaction, because that might add to this whole surprise. So to talk a little bit about what's inside of the black box, I want to use an example. So one of the very exciting topics of new technology is the distributed ledgers, and blockchain, as Ted pointed out, is one of those examples. So I'm going to talk a little bit about Bitcoin. Bitcoin was created some 10 years ago by Satoshi Nakamoto. And this is not a person, it might be a person, it can be a collective, it's at least a people or person that wrote this white paper that said, we need to think a little bit differently about how we are going to, how this whole financial system works. And it's being maintained by Bitcoin devs. So the thing is that this is open source. This means that we can actually look at the code. We can look inside. So what does it look like? How is it structured? And if you go to GitHub, which is a repository where people can kind of work together on code, you see that there's quite a bunch there. So basically, this is all the code that runs the Bitcoin protocol, the network, validates blocks, and the wallet. Everything is inside of that repository that you see over there. And it actually looks like this. So I don't know how many people in this webinar have seen code or coded themselves, but this is what source code looks like. And this is actually a very important one because this is defining the genesis block. So the first block in the chain. So there's a couple of things that we can do here. We can look at it from a component perspective, like how many components are actually in there that define this technology. Components mean code that belongs together, that is logically structured in one section. And there's a bunch of files there. So 730 files make up this Bitcoin solution, which amounts to around 120 lines of code. So 120 of these, 20,000 of these lines of code kind of built this solution. But Bitcoin or blockchain is not a technology per se. So it is a solution, it's an idea, it's a concept. But you build it using a programming language. So here C++ and Python are used to kind of build this whole thing. And the total investment time, so if you were to rebuild everything that a Bitcoin currently is, one person that understands these languages and understands the solution would take around 11 years. But to put that a little bit into perspective of how much we're talking about here, it's similar to the amount of lines in all the pages of Tolkien's Lord of the Rings and the Hobbit books, times 2. So this is the whole thing. And you can understand that this is quite a bunch that you need to go through if you want to do proper diligence on a system like Bitcoin. And if I compare this amount of, let's say, text or code to the averages that we see, then it's even a little bit on the smaller side. So typical applications are 4 times as big as this. So of course, also code doesn't read like a novel, it doesn't read like a book, but it has kind of similarities. So if Tolkien were to kill off a character, say Bilbo Baggins in The Hobbit, for instance, it would have a dramatic effect in, you know, the Lord of the Rings books. So similar, it works kind of with code. If you change something here, it might have effects on all the other things. So it's very important to think about what is then the risk and how can we actually define if it's built in a proper way. So what we do is we use the ISO 25010. This is an international standard that describes software product quality, and it breaks it up into these 8 characteristics. And this is actually a description. It's a definition created by the International Standard Organization that we can read and we can understand and we can build quality models upon, which is something that SRG has done. So what does this mean? Well, if a system is very maintainable, it means that developers can work on it in an efficient and effective way. And you can remove, for instance, technical debt, and you can add a lot of functionality quicker than if the code quality or the maintainability is lower. So from a security point of view, is the code actually free from any privacy or security flaws? And you know, do we know when somebody breaks into the database and steals some data? Is there enough logging going on? So this is also a concept. Or portability. So a lot of customers we help with migrating older applications to, for instance, a different architecture or a different infrastructure. So how easy can we do that? Or performance. Definitely interesting if you think about this small tech firm that maybe has 1 million or a couple of million users that now needs to integrate and perform at a very higher level in your enterprise organization. So these are all concepts that are very important. But there's one thing that we as SRG find a little bit more important than all the other ones, and that's the code build quality. Because if the quality of the code is really high, it's easier to change any or to mitigate any security risk or security flaws. So we build a model around this. And let's apply that model to the Bitcoin code because it's open source. We are allowed to use that under the MIT license. So it scores pretty low on the model. It scores 1.8 stars on our model. I'm not saying that this is bad. I'm also not saying that it shouldn't score higher, because typically in our process, we talk a lot with the lead developers, architects, the people that built this, to have good discussions on why it is what it is and what this means. But you know, just running our tooling and looking at it from this perspective of quality, there are a couple of things that stand out. So it's pretty small. I'm not going to go over all these metrics, but these are basically things that you can measure, factually measure in code. And you can see that it's not that big. The complexity of the units, which are the smallest parts in the system, are very complex. And from an architectural point of view, so how the components talk with one another, it also scores pretty low. So what does this mean? Well, this means something for productivity. It means something for a person, say a developer, that needs to understand a piece of code that maybe this person hasn't written themselves. So we did a bunch of research looking at what these star ratings means with actual time spent on feature development. And there's a big difference. So it's almost 4 times as fast as you compare a 2-star scoring system with a 4-star scoring system. So the code quality aspects are very important, but from an integration point of view, and this is a very important point, if you want to acquire a tech startup, you probably need to really understand what this architecture looks like and how well this will integrate in your current environment. So therefore, we need to measure that. And here you can see in the Bitcoin, it is kind of really complex. And these red lines, they mean that there are all kinds of calls going back and forth, that you cannot just change something in this one file because it will have an effect somewhere else. So if you go and look at it from a plug and play situation where you just say, hey, this tech firm is interesting, let's just buy this tech and plug it in and everything will be fine. That probably won't happen. Maybe it's so. Maybe you can build a wrap around this with a communication layer and you can just let it talk with your current environment. That's great, but first you need to know that that's even possible. And that's the whole point of showing you this. So we definitely need to change code all the time. So we need to understand before we do the acquisition what the quality of the code actually is. But you can also translate this very technical stuff to financial stuff. So when we talk about technical debt, it's actually a metaphor that equates software development into financial debt. It means that people have been working in such a way that they didn't do the ideal thing. So they took a couple of shortcuts. Maybe there's a very good reason for that. Typically what we see at startups, they want to push out functionality as quickly as possible and not think too much about all the quality of the code. But this accumulates to something that you need to worry about if you acquire this startup. So if we apply this to Bitcoin, I'm not saying that the code value of Bitcoin is just 2 million, because it's the business value of Bitcoin is of course way higher. But if we look at it from a very technical perspective, how much would it cost to build this exact same code? It would be around 2 million. But also the technical debt, which you see here, this is something that you need to invest to get it on an ideal quality level. And what this ideal quality level means, that's different per situation. You need to think about it. Do we need to change this like all the time? And is it very crucial to the future of our business? Then yeah, you might need to alleviate this technical debt. But it's very important that you are aware of this. So that was the topic about the product. Let's talk a little bit shorter though on the dependency of people. And of course, all kinds of HR due diligence is being done when there's a transaction going on. So typically, staff members and the founders, the owners of the company, they're offered a retention program because they're the glue that holds everything together. But also, the staff, for instance, developers, well, there are a lot of interviews going on, resume analysis and all that stuff, which is good. That's good practice. But when you think about it from a very technical perspective, and this is what we always try to do, we use a different approach, which is repository data mining. Basically, what we do is we go back in time to look at every contribution of all the developers throughout the life cycle of this entire product. And there you can see what your dependencies are on particular developers. And to make that a little bit visual, this is not Bitcoin, this is just an example that I pulled up. So for instance, when you have 4 developers, and there are different types of technologies. So remember the C++ Python for Bitcoin, but you have hundreds of different programming languages. Some of them are very modern, some of them are very old. And if you know that, and know that just developer C has been working in this legacy part, it's very good information to have, because then you know that you need to give this person a retention program as well. And this person doesn't have to be, the best programmer in the world, the most productive, the most senior guy out there, or the most articulate one. This might be somebody that's just really brilliant and is doing all this stuff that you, well, basically, to my point, need to be aware of. And there's another perspective that you can put on this, and this is you can map those contributions on parts in the code base. And this is what we call a functional knowledge dependency. So people are working in particular parts of the system. They build up knowledge there that you might need in order to understand it. So I once ran into a situation in a due diligence where there was this very brilliant guy, but he was very shy. So he wasn't very good at this interview thing. But when we looked at the code, we saw that this guy was actually doing pretty awesome stuff. So this was not the initial response from the HR diligence team. But when we look at the code and look at his contributions, it was actually very good. What we also discovered is that this guy built his own vault, which stored keys and a certain amount of data, which is something that is very scary to have in the mind of just one person, because his peers didn't know about the entire solution. His boss didn't know about the solution. The owners didn't know about that solution. But it is a very key component, or it was a very key component in that situation. So with looking at the code and looking at contributions, you can actually find these risks. So that's the point, like all these different things, they can add to this surprise that you don't want to have when you actually acquire the company. So the last perspective that I wanted to talk about is the software development process. So what you can see here is a quadrant, and we mapped here the different development processes that we saw in 350 different development teams, and we mapped them on this quadrant. So in the lower left, you can see legacy. So teams that score there, they are primarily concerned on or working with legacy technologies that are not very mature in terms of tooling assistance. You cannot do a lot of automated testing there, which is something that you actually really want, but sometimes it's just not possible because the technology doesn't allow it. And they have a very waterfall way of working. So they plan the execution and they do all this stuff, and then sometime in the future, something will be in production. It's a very little bit of an older way of working. So when you go into the startup, so the teams that are operating here, these people, they are really focused in delivering functionality as quickly as possible. Because when you are a startup, you want to test that your solution is actually doing stuff for the people that you're creating it for. So you want to have quick cycles. So they don't have a waterfall way of working. They have a very agile way of working. So they focus on speed a lot. So continuous integration and deployment. If you make a change in the code, it needs to be deployed on the server as quickly as possible, because then we can use it. We can see what it does for our users. So this is kind of the startup section. If you look in the lower right, you've got the traditionals, which are primarily the bigger companies, the bigger firms, the ones that they want to have, standardized tooling, because we looked at it from a security perspective, a mature requirement and planning process, a rigorous test suites, code quality guidelines. This is the concern of teams that are here in this corner. And the leaders, that's kind of the best of both worlds. These are doing DevOps. These are doing all the kinds of cool things that are really the leader in this space. So this tells us a little bit about the flexibility of the development process and the level of control of the development process. So why point this out? Well, you never know what kind of process a team is using if you don't ask it and don't look at, so what is the way that you document? What kind of tools do you actually use? How do you configure them? And all kinds of questions. And in total, we always ask around 130 different best practices, like, do you do this? Do you do that? So the point here is that if you're acquiring a startup and they work in a completely different way, they want to go fast, and you are in a traditional space where you say, hey, yeah, you can go fast, but we need to do rigorous testing. We need to do all this stuff. This can mean a culture gap. This can mean a different way of working, which can have an effect on how long it will take until these different teams can work together seamlessly. So there can be all kinds of communication issues. It can lead to frustration. It can lead to all kinds of things that you don't want. So that's the point of looking at the process in a very factual manner. So rounding up my section here, and then we would go into Q&A. So the most important thing that I wanted to bring across here is that we need to establish a fact-based and common understanding of the state of the product, the people, and the process. And this will lead into more trust between all the stakeholders. So it's not just you doing IT due diligence on them, but also doing IT due diligence on your own environment and thinking about how can we communicate the best and how can we integrate this the best. So 3 questions that I think you should always ask before closing the deal. What is the quality of the architecture and code of the product, and how well will this integrate with our own environment? What is the dependency of the key personnel? Meaning we need to look at their contributions in the code that will really successfully integrate or realize our roadmap, or reducing the risk of the integration. And lastly, what is the maturity of the development process? So we need to think about this from a cultural perspective as well, not from a human level, but from how developers like to work, and that it needs to match with your own teams. So the most important thing is always look at the code. That's very key. So you can have good conversations, you can look at architectural diagrams and all kinds of stuff, but actually assessing the code and understanding how it works, that is key for successful integration. And with that, I think I'm going to give the word to Charles. Are there any questions that Ted and I need to address?
Yep, a few questions came in. Thanks. And I think this might be mostly for Ted, but perhaps you could chime in as well, Jasper. So the question is, how can IT influence the process? What is the responsibility of the CXO, CIO, CTO during an acquisition? And Ted, I think you did have a slide on that, but maybe you could elaborate a little bit.
Yeah, no, I think it's a really important question. So at Forrester, we do a lot of work with the IT organization, with marketing organization, the business organization. So we're often, and I personally am often put in this position where I'm trying to essentially broker a conversation between all the various stakeholders. And it's a challenge because a lot of times there's different words people use to mean something. So I think a lot about this question here, which is why I put a slide. So I'm glad we're going to follow up on it. The thing that's different in this realm that we live in, the digital realm, is that companies have finally acknowledged the critical contribution of technology to their success. This should have happened a long time ago, and in some companies it did. But now I don't think we have a single client that we work with that does not recognize that they must transform, they must use technology as a business asset. So that elevates the opportunity and the responsibility of the technology organization. Of course, there's lots of keep the lights on type, very important, critical operational contribution that IT makes, but increasingly, IT makes a contribution that is architectural, that it is innovation, that is fundamentally transforming the way a company thinks. So that means that to be technology driven, to have technology driven innovation or technology driven transformation, the role of IT is increasingly important. To earn the respect of business and marketing and financial stakeholders in your firm, IT has to step up and provide the capability, provide the vision, provide the guidance and the guardrails. And so this is a place where, and we talked about it, but this is a place where having suppliers that can help, having a perspective, having a set of themes to go after and develop become increasingly important. So I just think it's an opportunity here to say, if there's going to be a startup that comes on in, how can we be part of the success of that acquisition and growth? And so I see it as a career opportunity. I see it as a skills opportunity. I see it as a real contribution you will and can make to the company. So want to make sure people understand that and feel good about it. And if they need help, well, they should look for help, but they definitely should own the responsibility they've been handed.
Okay, great. Thanks. Another question. How is the SIG process different from code scanning or the approach of traditional consulting firms?
Right. So there are different ways to look at that, and I showed you this ISO perspective, right, with all these different characteristics, and we believe that you should look at it from a holistic way. And I'm not saying that there are not tools out there that can do that. There are tools out there, but it's about, and the code scanning, understanding the facts and all the metrics that come out of there, but also align that with the roadmap and align that with all the metrics that come out of, you know, the target architecture, so to say. So we have a very rigorous process where we do that, and I highlighted a little bit during this webinar, is that we just don't run a tool. We want to understand what happened. We want to understand how it works. We are going to have very deep technical interviews with the people that actually worked on that, and we also want to have that common understanding. Like, hey, our tool is saying this, but what do you think? You know, what is the reason for this, and what it means? So I think that's the biggest difference. And there's another thing, is that we do a lot of benchmarking, right? So well, we measured over 4,000 enterprise systems, and that built up a database of 26 billion lines of code. So that's a lot of Tolkien books, I would say. And together, you know, with all that insight, you can do a lot of things. So when we see an application in a certain programming language, we can compare it, and we can say, hey, how does this compare to what else we see in the market, and what should you focus on? So I think it's that combination that makes SRG very unique in its approach.
Okay, and I think it's maybe a very similar question, but a little bit more specific. So someone's asking, in terms of code analysis tools, we're already using Black Duck. Are we covered?
Well, no. And I think that, again, this perspective of you need to look at maintainability, security, architecture, all these different things, it might mean something different in certain situations than others. And of course, Black Duck is good. We use Black Duck ourselves as well, where we look at IP risks, for instance. Is the implementation of all the libraries and frameworks that we use, is this implemented in the right way? And Black Duck can give a lot of clarity there. but you're definitely not covered. Certainly not on this quote quality thing and the architecture integration part.
Okay. Question. Okay, so how can we identify and bridge potential culture gaps between the acquisition target and the acquirer? That could be maybe for Ted or Jasper.
Yeah, let me start, Jasper, if you don't mind. This is hard. This is really hard. I'm going to give it to you straight, and Jasper, you can put your spin on it. So when you are standing up a new business that's technology driven, you need to stand it up separately. You need to put that organization in a different building. This is what Goldman did with Marcus, for example. Cake is a spin out, wholly owned subsidiary, Pinnacle Assurance. So when you do that, then you protect it. And that organization can do the acquisition and essentially assimilate the culture of the acquired company. So that's kind of the truth of it. And I'm talking to a senior executive, that's what I tell them. If you are already up and running and have a culture that is thriving, then it's a matter of bringing in and not losing the cultural elements that make the startup successful. And so a lot of companies do this. IBM is quite well known for doing this. They, of course, have the big blue culture, but when they acquired their way into security, they acquired the security culture of the firms they acquired. So you definitely don't want to lose that if it's possible. But I will say it is hard. So sorry, Jasper, over to you on this.
Yeah, so I agree with that. And the word culture, it can mean so many different things. And I highlight a little bit from our perspective when we look at how teams work. I think that's most important, and it is very, very difficult thing to do. But it is, I think, the most crucial thing. But that's the whole point I'm trying to make here, of course, is knowing that how do people work? What do they find important? How did it came to be? So you can take this into your plan. And sometimes indeed it makes sense to first establish a separate company from that. But sometimes maybe it overlaps, and it's just a little thing about, normally I would, wash my own cup and now I need to do something else, right? So you can just use the dishwasher. It's a bad example. I'm sorry about that, but you understand that there might be completely different ways of how people look at, especially, how we build code, how we work together. And that's in the end, my answer to that question is it is a technical product. So you need to think about it from this technical perspective of how do developers see this.
Okay, thank you. Now a question on technical debt. You talked about it briefly, but what's its origin? How does it come about?
Yeah, so there are different ways on how you can do programming, and it aligns kind of with this whole storyline. Is that if you want to build something fast? So basically, you got a couple of concepts here. You got time, you got money spent, and you got quality, and you can choose two. This is a very simple way of explaining that. So if you want to go fast, and you didn't have all your investment cycles yet, you need to make shortcuts. And this is typically what happens when technical debt accumulates. It's just a different way of programming. Copy pasting is a very good example. So you can programming in such a way that you do it smart, that you can reuse parts that you already created. Or, if you need a similar functionality, you just make a copy and make some changes, and you do that 1,000 times. And now you're blowing up your system, and there's all kinds of things that basically do the same thing. And this can really have an impact on this technical debt. And it depends really on what it depends really on what you need to do if you really need to alleviate this or remove this technical debt. But this is the most important thing. I think it's a way of working, and it rarely has to do with people not caring about the quality of the product. It almost always has to do with we need to have this functionality tomorrow or now or whatever. And this makes people use shortcuts. That's the general idea that I have about that.
Okay, thanks. And then another question, you're capturing a lot of data and drawing conclusions that can have a big impact on the success of a roadmap. How do you know that data is accurate? What's it really based on?
So validation is a very important thing. Is that whenever we have the results that we validated with people that worked on the code. But another thing is that we have this certified laboratory, right? And this means that we work in a very, very structured way. The input of the whole process is very important. And the way that our analysts work with the code, it's very structured and it's all described. And therefore we have this certification. But you know, the validation, I think, is a very crucial step in our whole process.
Okay, thanks. And it looks like we're running up against time here. I think additional questions, we'll try to respond to them, provide written answers, and share with everybody after probably within the next week. We'll also share a link to the video of the recording. But thank you very much, Ted and Jasper, and to everyone who attended today. We hope you found the discussion informative. Yeah, if there's any feedback that you all could provide on how we could improve these sessions, that would be great. But thanks again to everyone, and have a great rest of your day.
Thanks a lot.
Bye-bye.
Bye-bye.